right, solving radical equations. First, you have to isolate the radical to one side of the equation. Next, you have to raise each side of the equation to the same power to remove the radical, and then simply solve the equation with algebra, just like you used to. Example 1. This is all underneath the radical sign. So what we're going to do is we're going to take and raise each side to the second power. This removes the radical, which gives us x plus 25 equals 16. Then you simply subtract, the 25 from each side, and you get x equals a negative 9. Just for funsies, we're going to check it. See if we're right. We plug in the negative 9. Negative 9 plus 25 equals 4. So the square root of 16 equals 4. So 4 equals 4. It's true. It works. Now number 2 is a little bit more difficult because you have the radical with the x minus 6, but you have an x minus 8 on the other side. So if I were to square each side, this left side just is x minus 6, but this right side uses the rule when in doubt, write it out, and you're going to have to FOIL. So you're going to get x minus 6 equals x squared minus 8x plus 64. We're going to bring everything over to the right-hand side and set it equal to 0. So minus x plus 6 plus 6. You're going to get 0 equals x squared. Now negative 8x, and negative 1x give me a negative 17x. And 64 plus 6 gives me a happy 70. You're going to factor. Factoring is never leaving. It's always going to be here. And this should be a pretty simple factorization. X and x, I'm going to do a 7 and 10, a minus and a minus. Because that will give me my middle term, but a negative 7 times a negative 10 will give me the positive 70. So I'm going to get 0 equals x minus 7 and 0 equals x minus 10. So x is going to equal a positive 7 and x is going to equal a positive 10. There we go. You are going to have to check them to see if it works. So come up here with me and we'll check. All right, so we're going to put in the 7 first. This is when x equals 7. So you get 7 minus 6 equals 7 minus 8. This will give you the square root of 1 equals negative 1. 1 does not equal negative 1, so we reject this solution. And I'm going to change to this ugly green and check the when x equals 10 right here in the middle of the board. So the square root of 10 minus 6 equals 10 minus 8. The square root of 4 equals 2. 2 equals 2. This is a solution. It does work. Take a minute, pause, write it all down, think about it. All right, we're ready to go with example 3. Again, we're going to have to square both sides. And we have the when in doubt, write it out action happening over here. And here you're just going to get 7x plus 15. When you FOIL this, you'll get x squared plus 2x plus 1 equals 7x plus 15. We are then going to have to move everything to the left to get it set equal to 0. I'm going to subtract the 7x. I'm going to subtract the 15. This all cancels out and goes to 0. X squared minus 5x minus 14. Then you factor. Factors of a negative 14 that add to a negative 5. Well, it's going to be x minus 7 and x plus 2. So you get x equals, let's go back, x minus 7 equals 0. And x plus 2 equals 0. So x equals a positive 7 and x equals a negative 2. Now, we're going to have to check them. Not your favorite, but when we plug in 7, 7 plus 1 will equal the square root of 7 times 7 plus 15. Oh, gonna have to do some multiplying. This is 8. Here we'll get 49 plus 15. My pen's not working. There we go. So we get 8 equals the square root of 64. So 8 equals 8. So this one, he's a winner. Then we'll check the negative 2. So you have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. This will give you a negative 1, so already we're a little cautious. We're a little worrisome because this should never be negative. Just saying. So then you get the square root of 14 negative plus 15. Negative 1 equals the square root of 1. Negative 1 does not equal 1, so we are going to reject this answer. All right, moving along to example 4. I'll do it in red for you. If you have the square root of something not equal to the square root of something, if you simply square them, this one becomes infinitely easier. 2x plus 5 equals x plus 7. Subtract the x from each side, you get x plus 5 equals 7. Subtract the 5, you get x equals 2. Easy peasy lemon squeezy. We're going to check it. Make sure it works. 2 times 2 plus 5 should equal 2 plus 7, all under a square root. This will be the square root of 9 equals the square root of 9. Well, that's true, so this works. It's good. All right, example 4, same process. We're going to square both sides. And hopefully remember that there is going to be 2x plus 3 that you will have to FOIL. Write it out. So the 10x plus 9 will equal x squared plus 6x plus 9. We are going to take everything from this side over to this side so that we can get it equal to 0 and we can factor. So minus 9 minus 9, minus 10x minus 10x. This gives me a big fat 0 on the left. I'll get x squared minus 4x, and the 9's cancel out. And this is the point where you all are like, oh no, I don't know what to do. Okay, that was the bell. But it's simple. You just always want to look for a GCF. So we're going to take out an x, and get an x minus 4. You're going to set each piece equal to 0, so x equals 0, and x minus 4 equals 0. So that means these are our two solutions. Easy enough. Go ahead and check them. See if they work. But I'm going to move along to this problem. And I think that if this is under the same radical, then this is x plus 4 equals the square root of x minus 2. Simply just square both sides, and you get x plus 4 equals x minus 2. If I would subtract the x off both sides, I'd get I'd get 4 equals negative 2. This is not true. This is a no solution problem. No checking involved, nothing you can do, no solution. All right, now we have other radicals. This is the cubed root, so to get rid of the cubed root, you're simply going to cube both sides, which means you're going to have 2x plus 7 here. But on this side, it's like saying 3 times 3 times 3. 2x plus 7 equals to 27. Let's subtract our 7. 2x will equal 20. Divide by 2, x will equal 10. Let's check it. And so you have the cubed root of 2 times 10 plus 7 equals 3. So the cubed root of 20 plus 7 equals 3. The cubed root of 27 equals 3. And remember, cubed roots are either positive or negative based on the sign inside. This is a positive 27, which is really like saying it's 3 times 3 times 3. Or 3 to the third. still equals 3. So we say 3 equals 3. Therefore, it's a solution. We're good. All right. What do we do on 8 when there's this 2 out here? Well, before you even start, the radical has to be isolated. To isolate it, you're going to divide each side by 2. And you will get the cubed root of x minus 3 equals 2. Then you simply raise each side to the third power. And you get x minus 3 equals, well, 2 times 2 times 2 times 2, maybe 3 2s, or 8. You add the 3 to each side, you get x equals 11. Go ahead and check that. We'll go over it when I get back. 9. Ooh, 9. You're going to have to isolate this before you cube anything. So we're going to add the 13 to both sides. That's going to give you the cubed root of 12x equals what? What's going to be positive? 6. Then you're going to have to cube each side. So this just becomes 12x. But 6 cubed is 216. Then you'll simply divide each side by 12. And 216 divided by 12 is 18. 18. That's enough for this video. We will continue the rest of the examples in the next video. So see you then.